Some example problems from your assignment. When I say the square root of negative 4, first of all, I want to point out that you cannot take the square root of negative 4 because there's nothing times itself that makes a negative. A positive times a positive, any number times itself makes a positive, and a negative times a negative, a number times itself makes a positive. There's nothing times itself that makes a negative number. This doesn't work and brings up some different mathematics, which we're not going to talk about. But notice the negatives in front. It's just like when you say negative 3. That's the opposite of 3. Well, this question is the opposite of the square root of 4. And we know that the square root of 4 is 2, and the opposite of that would be negative 2. So just bring the sign over with it, with your answer. On the next one, evaluate 16h squared. The square root of 16h squared, the square root of 16 is 4, and the square root of h squared is h, because h times h is h squared. On the next one, the square root of 49y to the fourth, the square root of 49 is 7, and a number times itself that makes y to the fourth is y squared. Remember, y squared times y squared, you add your powers, is y to the fourth. So the square root of y to the fourth is y squared, because y squared times y squared is y to the fourth. On the last one here, I'm just going to point out, this is something you wouldn't pick up on your own, but the square root of 36 over 49 is the same thing as the square root of 36 over the square root of 49. This is useful sometimes in certain situations to split up the root. These two are the same thing. The square root of 36 is 6. The square root of 49 is 7. So the answer is 6/7. Five square root of 12, 5 radical 12. This is one of those where you have to have a perfect square to simplify it. Perfect squares are any number times itself. 4, 9, 16, 25, 36, 49, 64. These numbers are the key to simplifying square roots. You have to have these numbers in the back of your mind, or you can't simplify a square root. There are technically an infinite number of perfect squares, but for our purposes, up to square root of 400 was 20, is about as far as you need to go. Most of them are going to be in here amongst these first ones. And what you want to do is find the largest perfect square, one of those numbers that divides into your root, 12. So looking at the numbers above, it has to be one of those numbers. I noticed that 4 goes into 12. In fact, 12 is 4 times 3. Now, between the 5 and the root is times. There's multiply right there, mult. So when I take the square root of 4 out front, it goes out as a 2. That 2 has to be multiplied by what's there, because there's times between the 5 and the square root. So the square root of 4 is 2. 2 times 5 is 10. So 10 root 3, or 10 radical 3, is your answer. I'm going to do another video on simplifying square roots because I noticed some people are having trouble. And it is one of those things that takes a little while to get used to, but once you pick it up, you'll get it. Now these next two you're going to like. They do get more complicated, but for now, this is what we're doing today. 8 root 7 minus 2 root 7. The way square roots work when you're adding and subtracting is it's just like variables. I can only add and subtract like terms. And you know how 8x minus 2x is 6x? Well, 8 root 7 minus 2 root 7 is 6 root 7. In fact, it's exactly the same thing. This is the same concept. Same concept. When you're adding and subtracting like terms, you're using the relationship between multiplication and addition. It's like when I say 8 times 10 minus 2 times 10. That, in fact, is 6 times 10. That's what's going on here. I have 8 of some number. I'm taking away 2 of that number. I have 6 left. And it works the same way with roots. So to add and subtract roots, you have to have like terms, meaning the square root part must be exactly the same. If, for example, I said 8 root 5 minus 2 root 7, you can't do that. You can't simplify it unless you approximate. You'd have to punch it into the calculator and get a decimal. That's not what the goal is here. The goal is to simplify square roots. So understand you can only do that if the radical part is the same. All right, last example here. 8 root 17 minus root 17 plus 9 root 17. Well, as you do this, think of something you know. This is like 8x minus x plus 9x. It's the same exact thing. They're like terms because the radical part is the same. So if I said 8x minus x, that'd be 7x. 7x plus 9x is 16x. And so up above, 8 root 7 minus 8 root 17 minus root 17 is 7 root 17, plus 9 root 17 is 16 root 17. Again, these two are the same concept, but we're working with roots.